One, a new startup in the field of serverless security, and I'm here to speak today about achieving least privilege IAM permissions for AWS Lambda. So a little bit about AWS Lambda for those that are not too familiar. So it's a technology that was introduced by Amazon at actually almost 4 years ago, 2014, in reInvent. It went production around 2015. These are actually slides from the introduction at reInvent. And basically, it's a new way, Amazon at least markets it as a new way to build applications, and lets you focus on building your application only on your business logic and running code, and not working with, not dealing with what's called infrastructure or the heavy lifting, the way Amazon likes to call it. It's also referred to as serverless technology, where you're not managing servers, you're focusing on code, you're paying only per request, so you're not paying for idle time. And Amazon takes care of all the auto-scaling and everything. It's basically all about functions. That's why it's called Lambda. Lambda is a function. Also referred to as function as a service. Your function is executed by Amazon. It's triggered by an event. It could be, for example, a web request such as coming from API gateway. It could be also other stuff coming from SNS or queues and so on. The function is stateless, and basically it performs your business logic, but since it's stateless, it's mostly communicating with other services in the ecosystem, usually Amazon services, and it's using the Amazon APIs to communicate with those services. And you might ask, okay, so what kind of permissions, how does this function deal with permissions regarding services? So the way Amazon manages permissions to services, it's via what's called IAM policies. So for any service that you want to access, for example, Xray, DynamoDB, and so on, you need to have permission, explicit permission, and this is defined in an IAM policy. So we have here two examples. One is for Xray, the other one is for DynamoDB. What I wanted to emphasize is pretty much the syntax. The syntax gives permissions. By default, you don't have any permissions, and you add statements which provide you allow execution on these resources. You specify the action, what kind of actions you want to do on each resource, and you can also specify the resource with quite detailed, what the resource you're trying to access. And some of the services, such as Xray and so on, also have conditions which you can specify to even get even finer grain access. So how does this connect to Lambda? Lambda basically, for each Lambda that you define, you can connect to it a role. The role contains IAM policies. They can be either managed policies or inline policies. Managed policies can be shared between different roles. And Lambdas can share also, different Lambdas can share a specific role. So as a best practice, we want to reach a state where we're running our Lambda functions, what we call a principle of least privilege, meaning that we want to provide the permissions that we're giving our Lambda function, only the necessary permissions, the minimal permissions needed for that Lambda function to perform its task. And you might ask, why do we want to do this? So the motivation behind this, and especially when we're talking about Lambda functions, is basically Lambda functions introduce kind of like what we call a microservice architecture. It's a picture from Jan Pui, which is a blogger writing about serverless. It's worth checking out his blog if you want to learn about serverless. He has a lot of entries. He actually has also a course. But this picture that he did here is actually a monolithic application which they took at the company where he worked with, and they transformed it into a serverless application. All the orange dots there are actually Lambda functions, each one of them representing a microservice, doing a very specific function, such as accessing a specific table, posting to a queue, and so on. And when we're talking about least privilege permissions, what we want to do is really make sure that each of these functions can only access the resources that it needs. So for example, if there is a vulnerable function in one of these microservices, it allows us to make sure that if there is any kind of attack, it's very contained, just to the data that was being available for that function, and not a state where there is an attack of a vulnerable function, and suddenly, because we gave too wide IAM permissions, this function, this attack can actually access a lot of data that's not even relevant for that function, and exploit that data, obviously. So we we want to reach least privilege IAM permissions for our Lambda functions. It's good to minimize our attack surface, but doing this is actually not that easy. Defining these IAM permission policies is not an easy task. First of all, there are a lot of AWS services. There are over 130 AWS services. Each one of them has their own set of permissions syntax. So you have over 3,000 permissions. And Amazon is constantly adding new services and also improving the existing services. So constantly adding new permissions and so on. And there's syntax differences between the permissions. This basically leads to a state where if you have developers that need to define these IAM policies, they get lazy, they get tired, it gets too complex, they don't want to learn it, and they use what's called, you have the option of defining the star syntax, basically giving very wide permissions, saying, okay, you can do everything, I don't want to mess with doing fine-grained permissions. Additionally, there's an issue of education. A lot of examples you see actually use the star syntax. And people just copy these examples and use them, and it stays there, and it goes into production code. For example, this is a built-in IAM policy that comes built in with the AWS console of AWS. It's used in a lot of examples at the tutorials that AWS shows. And it's called the AWS Lambda Execute IAM policy. So you would say, wow, I should be using this for my Lambda functions just by the name and seeing it used in tutorials. And it actually provides star access to all S3 buckets. It allows you to do get and put on your buckets. And it's usually, when you're writing a Lambda function, you don't want to have access to all your S3 buckets. It's usually dealing with a specific bucket. Another example from the official GitHub AWS samples repository, which is maintained by AWS. One of their crude examples, you can see I highlighted in yellow. Basically, as a pre-request set, they're asking you to create a role, call it Lambda role. This is going to be used for your Lambda functions in this tutorial, which they do. And assign it what they call the AWS Lambda full access and Amazon DynamoDB full access IAM permissions policies, which allows you basically to access all your DynamoDB tables in that environment and so on. Additionally, as I said, roles can be shared between Lambda functions, and managed policies can be shared between roles. This adds additional complexity. And as I said, people are lazy, so they want to create, they create a role once, and then they share it between their functions. And obviously, when you're sharing a role between functions, you're not assigning to each function the minimal permissions. You're assigning it the global permissions that the whole whole application is using, or those that are sharing those that role. Additionally, there's a very good framework called the serverless framework, which is very popular for managing Lambda functions, and this actually uses by default a shared role between functions, and you would see a lot of examples and a lot of tutorials which are using this framework, and they promote this kind of form using a single role for many functions. So obviously when you're using a single role for many functions, they're not running with a minimal permissions. We actually took a real-life environment and we mapped out kind of like on a permissions base between Lambda functions, roles, and DynamoDB tables. Put this into a graph database and generated this image. On the left side, you see the Lambda functions, those are the purple ones. Right side, DynamoDB tables, the orange ones, and in the middle, we have the roles. So you can see the relationship and how complex it can be. And this is a real-world environment, not very large, but as it grows, you have roles which are being used by multiple functions. You have roles which are giving very wide access to a lot of tables. And just analyzing this from a perspective of looking at this and understanding what's really needed and what's not when you want to minimize your permissions is a very hard task. This leads me to our open source tool, AWS Least Privilege. So we wanted to create a tool to help developers, help admins tackle this problem. How do they reach a least privilege setup and do it really efficiently and easily? So what we created a tool, and the goal of this tool is to really generate the least privilege policy document that you can then copy it to your Lambda function. The way this tool works is basically it's looking at runtime information. Okay, we decided the best way to analyze what's being used by a function is looking at actually the runtime resources that it's being used and collecting that information and then analyzing that and generating a least privilege document. Where can we get that information? We can get it from AWS Xray. Xray is a service that's provided by Amazon. It's used for performance monitoring, but it also provides you very detailed input about what each operation of your function is doing. For example, it's accessing a DynamoDB table. What kind of operation is doing on the DynamoDB table? Is it a query? Is it an update? And so on. And we can use this information to generate a least privilege document by scanning the AWS Xray scans. It's a command line tool, and use cases that we see for it is one is during testing. So you can also use it in CI/CD kind of setup. If you have integration tests, you run your integration tests, then you can run the tool, and you can get the generated least privilege IAM policy. Additionally, we can compare the existing permissions that are deployed on this function and see if there's a diff, if there are excessive permissions. So we can actually kind of like break the build if you want, if you see there's additional permissions which are not supposed to be there. And we can also use it in production for, by example, by operations to scan periodically their production environment and get out a diff, excessive permissions which are deployed on functions. Okay. So next part, what I want to do is actually show a demo how we can take a real-world application, demo application. It's the Notes application from Serverless Stack. It's a site which is dedicated to build a demo tutorial. Walks you through the whole serverless flow of building an application. It has 5 Lambda functions built kind of like around the microservice architecture, each Lambda function doing a single task. And it shares a single IAM role because it's using the serverless framework. As I said, serverless framework uses this by default. I'll show how to set up AWS Xray. We'll explore a bit Xray, what can be used. And then I'll show the open source tool, how it's being used and what output it provides. And as a bonus, I'll show also how to fix this, and how we can deploy IAM permissions which are minimal on these functions using a different plugin which we released as open source, which allows you to define roles per function using the serverless framework. Let's go to our demo application. So this is a demo application. As I said, it's a Notes application, very simple application. You could go in, get notes, update the notes, just generating here a bit of traffic, create a new note. And each of these operations is actually mapped to a Lambda function. So when you're doing create, there's a Lambda function that does create. When you're doing update, there's a Lambda function that's responsible for update. One for list, another one for delete, and another one for fetching, and so on. And this is available from this site, serverlessstack.com. It's quite a popular site. Over 1,000 GitHub stars it has on their repository for this tutorial. And they actually walk you through the whole process of creating a Lambda function. They give you code, they write the code. So we can see the code here. The code is doing basically, this is the create function. It's calling a DynamoDB API to put in the object into the DynamoDB. And they also walk you into your configuration using the serverless framework. Okay, so you can define exactly how to set up your service, and they define here your IAM policy, which is going to be used by this service then. So they use a single role. Again, this is the default in serverless framework. They provide quite a few permissions, and these are all deployed for all your functions. So even if you have a get function, which is just doing get, it can actually do other stuff such as scan and put and delete and so on. Additionally, they were lazy and they defined this role for star access, okay, basically allowing you these functions to access all DynamoDB tables. And I actually exchanged with them emails about this, and they were like, yeah, we want to keep it simple during the tutorial. We don't want to complicate things because the person might have created a table, he might have created it with a different name, so we just put in star access. And they don't really talk about it, that you should change it or anything. So the first thing that we want to do for this application, we want to enable Xray. And I wanted to show how to do this, so just so show you how straightforward it is. Basically, enabling Xray, increase the code side, is adding these 2 lines of code. Well, you need to first, obviously, install the AWS Xray SDK. Do that with NPM. And this is relevant for JavaScript, but the process is similar for other Lambda environments such as Python, Java, and so on. Install the AWS Xray SDK, and then you run this initialization method, capture AWS, which then says that all AWS interactions with AWS services are actually captured, and Xray takes care of sending out information to their agent. The Lambda environment already comes built in with their collection agent, which collects these events regarding performance, takes those events, and it uploads them to AWS environment to see traces, create Xray traces. So how does it look in the console Xray? Basically, they create, first of all, a service map. Okay, zoom in. Service map maps out, for example, it gives you a function. In this case, it's the delete function. It tells you how long it's been executing. And it also shows you what's being accessed. For example, the nodes table is being accessed by this function. It's actually being accessed by all these functions in our environment. And it also creates traces. This obviously is already very valuable information. It's recommended to use this. Look at a trace. You can see again, it's the update function being used. It does a call to DynamoDB. And we can actually see that it's doing update item. That's the action that this function is doing, and it's doing this on the nodes table. Okay, so this information is very useful, and this is basically what our tool is going to use. It's going to use this information from the traces which were created to analyze all the Lambda functions in the environment and understand which ones, what resources are being accessed and how. Not only is it accessing the nodes table, but it's also doing an update. So our open source tool is available on GitHub. Okay, it's basically JavaScript command line tool. You install it by running npm install -g AWS least privilege. It does require credentials because we're accessing the Xray traces. So you need to provide a user which has, when you're running the command line tool, which has the read-only access to AWS Xray. Additionally, if you want to do comparison of existing permissions compared to what the permissions we found, so we need to fetch the existing permissions, again, read-only, so we need you to add these following permissions. When you're running usually from the laptop with an AWS account for development, you usually have these permissions already. It's not something that you'll need to add, but if you're running this in kind of like a batch environment, doing continuous monitoring, then you need to put up permissions for the user that's running this command line. Once we have that set up, we can actually go and run the tool. The tool itself is called Xray Privilege Scan. Let's run it. Try to get a little bit more output. So the options, pretty straightforward. You provide the tool a time range. You can also provide it a start time to scan the Xray scans. It'll go and scan, fetches the scans, analyze all the scans, extract the, what functions are involved, and then generate these privilege policy documents for each function. So I'm going to do a scan on a time range of 180 minutes. Let's do it verbose, and we'll also do with -c the option that says let's compare existing permissions with the permissions we found. Okay, so I'm running this. This is real running. Let's hope it works. Okay. Done a scan, found, okay, gives out a summary, it's completed. For each function that it found, it generates a policy document. We actually use, for the policy document, we name it according to the hash of the full ARN, okay? And we can go take a look. And additionally, finally, we also write the excessive permissions which were found into a document. Everything is JSON formatted, so you can actually feed this into kind of like automation tools to deal with this. So let's go to policy document. So this is the generated policy document. A bit smaller. Okay, so this is the generated policy document. It was generated for the create function, for example. And you can see it only has, the create function is only using a specific action. In this case, it's the put item on the nodes table. Very minimal permission compared to the wide permissions that were given before. Additionally, you can look at the excessive permissions document, which was generated. I'm going to take this down a bit. And again, it's JSON formatted. For each function, put out the list. For example, the list function, we specify what's the current role that's being used by this function, and what permissions are not needed by this function. So this can be processed by an automation tool. For example, if there's certain permissions that you want to put out an alert on, if you find out that are deployed and not needed by a function, and so on. And we do this for each function that we found. Okay. So now you might be asking, and we don't have a lot of time, but I'll do this really short. We got the minimal permissions. How do we deploy this to our application? So we've actually put out a plugin which helps with this. It's available on NPM. It's called Serverless IAM Roles Per Function plugin. Very original name. And basically what it allows you to do is define a role for each function compared to what we saw before, that we were using a global role. Very simple to use. What you do is install it. This obviously is only for the serverless framework, but I really recommend checking out the serverless framework if you're not working with it. It's kind of like the de facto framework for managing Lambda functions and other serverless environments. You install the plugin. Again, npm install, very simple. And then once you install it, you add it to the plugin definitions in the serverless YAML. And then you can actually define the same way that we were defining in our global scope permissions. We can actually define them in our per function. So we have here actually example serverless YAML. What needs to be done? We added following plugin. Okay, and we removed the global IAM statement, which was before, if we remember, which was giving global access to all. Is the one we had before, global, giving access to the nodes table, all these permissions. So we remove that. We do leave, and this is needed. I didn't specify this on Xray. We do need to provide for Xray permissions to upload the telemetry traces. So we leave this. This is shared by all functions, and the functions inherit this. The roles per function will inherit this permission. And then for each function, for example, the create, we can actually, same syntax, we can actually have the IAM statement. For example, create only uses the put. This we could have taken from our document which we were generated, copy it into here, and we have minimal permissions for each function. Okay? So just to recap the demo that we saw, looked at nodes application for serverless stack using a single, very wide IAM policy. We set up Xray. Once we have Xray, we can actually look at the Xray output. Our command line open source tool can actually go and fetch all the data from the Xray, analyze it, and generate least privilege permissions, least privilege policy permissions. And then, as a bonus, we also have the open source serverless plugin, which we put out for defining roles per function. And that's it. Ready for questions, if anybody. You can check out our GitHub repository, functional1/AWS least privilege. Feel free to open issues, suggestions, and so on. And you can reach me at guy@functional1. So any questions? Yeah, actually the tool can also work with other applications. Any application that uses an AWS role, so for example an EC2 application or ECS, we can also use that. But we see the most value actually in Lambda because it's really, I mean, when you're using a monolithic application, you can still, minimize the permissions for that specific applications, but it's less of a challenge compared to a microservice architecture where you have each one doing very specific tasks, and it's much more complex regarding permissions. Yeah, well, I looked at this a bit. What we wanted to do is really go fine-tuning the native stuff from AWS doesn't always provide the full detail. For example, what S3 bucket and the exact path which is being accessed. And Xray does provide all of that information. So we see that as a really best option to get this information. But we can also discuss, if you have ideas, I'm open for additional stuff to add to this tool. So it's open source and ready to go. Yeah. Okay, anything else? Selfie, okay. This is how we... okay. This is it? Okay. 1, 2, 3. Okay, thank you, everybody.